Hey everybody, so if you've been working on that Delta Math assignment, you've probably noticed that there's a lot of vocab terms that you need to know in order to do those assignments correctly. So I want to make sure that at the beginning of this video, we take the time to look at the correct definition of all of these vocab terms. So the first term that we've got is congruent, and that one's pretty easy. It just means that things are exactly the same. It's the exact same degree measure when we're talking about angles. So for congruent, our definition is, that marker's not congruent. Our congruent definition is the same degree measure. And remember, we've got a bunch of angle pairs that form that end up being congruent. Our second definition is in those diagrams when we're including parallel lines and transversals, most of the time you're either going to have congruent pairs or you're going to have supplementary pairs. And remember, supplementary, what does supplementary mean? Supplementary means that the angles add to 180 degrees. So they add to 180 degrees. And we said we knew this was true because if we looked at ones that were on the same line, they form a linear pair. So they create a line. If we look at a quick little drawing of what that looks like, these would be supplementary angles. Because together, if we look at those angles together, this angle and this angle makes up this entire line. So supplementary angles are angles that add up to 180 degrees. Now, if you've done a lot of the Delta Math already, you've probably already come across this word here at the bottom, which is complementary. Now, complementary is very similar to supplementary, except for instead of adding to 180 degrees, they add to 90 degrees. And that might be useful when we're thinking back to like the Pythagorean theorem, understanding that yes, we have a 90-degree angle in a triangle. So if I look at what that looks like, a 90-degree angle, remember, looks kind of like an L shape. That would be if we had like two angles in the middle, and we had this angle and this angle. Forgot to include the second part. And then together, both of those angles form a 90-degree angle. And we usually use a box to signify that it is a 90-degree angle. All right, the next two definitions that I want to look at are about adjacent angles and vertical angles. And adjacent is another one where if you've been doing the Delta Math, you've probably already encountered that word. And if you've encountered it, you might know what it already means. But adjacent just means that it's directly next to. So directly next to. Next to. So two angles that are directly next to each other. So if I look at a diagram here, I've got 1, 2, 3, and 4. I could say that 1 and 2 are adjacent. Because 1 and 2, they're directly next to each other. So angle 1 and angle 2 are adjacent angles. I could also say that 3 and 2 are adjacent. 2 and angle 3 are adjacent because they're directly next to each other. There's not an angle in between those two angles. So adjacent just means that it's directly next to. And then we've got this word vertical, which we've already looked at with parallel lines and transversals. But I want to make sure we're using our new definition to determine what that looks like. So vertical means that it's on the same vertex. And in fact, adjacent also means it's got to be on the same vertex. So directly next to, on the same vertex. So for vertical angles, it's on the same vertex, and it's just not adjacent. It's directly across from. So it's non-adjacent and diagonal from. Diagonal from each other. And then the last part of it is that they are congruent. And that's huge because that tells us that if we look at that a similar diagram to that one up there, and we have 1, 2, 3, 4, that tells us that we know that 1 and 3, angle 1 and 3, they're non-adjacent because there's an angle in between, but they're directly across from each other, and angle 1 and angle 3 would be vertical angles, which means that they have to be congruent with each other. Same thing if we look at 2 and 4. Angle 2 and angle 4 are also vertical angles because they're directly across from each other and they're non-adjacent. You have to go past the vertex to get them, or you have to go around another angle to get there. Our next one that I want to look at is going to take us to this diagram here. Now, I know I draw it like this a bunch, but it works for any parallel lines. This one is just kind of the easiest one to look at. So here we've got parallel lines, and what makes these lines parallel? How do we know that they're parallel? Good, it's because it's got those double arrows. That tells us that those lines are parallel. And then what do we call this line that cuts right through them? Good, that's the transversal. So we've got 8 different angles that we are looking at, and I want to look at what makes angles corresponding. And what corresponding means is we've got these 2 different vertices. We've got these 2 different sets of 4 angles. We've got 1, 2, 3, 4 here. We've got top left, right, bottom left. And we got the same thing down here. Top right, bottom left. And corresponding just means that they're in the same relative location, just on the other vertex. So I'm going to write that one down. They're in the same relative location, but a different vertex. And that should also tell us that, or we should also know, based on previous classes, that corresponding angles are congruent, and they are congruent. So when I look at this diagram here, we can start with any angle. If I want to look at number 1 here, up in the top left corner, I'm looking at that angle's relative location. I mean relative to that vertex. So my point is right there. Angle 1 is in the top left. So what I want to do is I want to look down at my other vertex and look at, okay, which one's in the top left? 5 is in the top left. So I could say that angle 1 and angle 5 are corresponding. Angle 1 and angle 5. I could look at angle 2. Angle 2 is up here in the top right. Relative to this vertex, it's top right, above and right. So now if I go to this vertex, the one that's above right is number 6. So number 2 and number 6 are corresponding. If I look at angle number 3, relative to that vertex, it's below it and to the right. Go to the other vertex. Which angle is below it and to the right? Well, that would be angle number 7. So 3 and angle 7, which you could probably already guess what our last one's going to be. If I look at angle 4 and angle 8 would be our last pair, because 4 relative to this vertex is bottom left, 8 is bottom left. So 4 and 8 would be corresponding, which tells us that 1 is congruent to 5, 2 is congruent to 6, 3 is congruent to 7, and 4 is congruent to 8. All right, so for these next two, since we already know these, we've already learned these, I decided to write our definition with the diagram switched up a little bit. So make sure you draw this diagram in your notes because sometimes it's going to look like this. It's not always going to look like where the parallel lines are running horizontal. Sometimes they'll be going diagonal, sometimes they'll be vertical. It just kind of depends where they are. So here, we've got our two lines. These are our parallel lines because they got the double arrows. And then our transversal is running mostly horizontal, but just kind of on a diagonal there. So for this one, we're going to say alternate interior. And remember, there's two parts to this. The alternate part, remember, means on opposite sides of the transversal. So if our transversal is this line going right through the middle here, I'm going to kind of draw it a little bit with green, highlight it a little bit. Transversal is that green line going down the middle. And then the other part is interior. And interior just means inside the parallel lines. And then the last part is congruent and are congruent. Because remember, we're looking at pairs of angles, not just one angle. So in order to do this, I have to pick certain angles. I have to pick angles that are inside the parallel lines. So if I highlight my parallel lines here, hopefully you guys can see this okay, but I'm going to highlight them in red. I've got my one on the left here, and then I've got my one on the right here. And I need the angles that are inside those lines. So my inside, if I make this into like a box, if I put lines at the bottom and the top, I need the angles inside that box. So if I choose an angle inside the box, I've got four options. I've got 2, 5, 3, and 8. Those are my four angles inside the box. So if I choose angle 2, if I look at angle 2, now I got to decide, okay, what angle is on the opposite side of that transversal? So 2 is above the transversal. So I'm picking an angle below the transversal. So it's either going to be 3 or 8. And then it's got to be inside the parallel lines. Good. So it's got to be 3 or 8. And then it's got to be congruent. So if we look at this here, this one is kind of an acute angle. It's under 90 degrees. Opposite side of transversal, also think opposite corner. So 2 is up here in the top left, 8 is in the bottom right. 8 is my angle that is congruent to it. So I would say angle 2 and angle 8 are alternate interior angles, which tells us that they are congruent. Which also tells us that my only other pair of alternate interior is if I look at angle 5 and angle 3, those are alternate interior. Angle 5 and angle, not 8, angle 3. Angle 5 and angle 3. So that's alternate interior. I bet you can guess what I'm doing next. All right, I got another different looking diagram, so you might want to draw this one down because this one might look a little bit different than the ones that you got in your notes, but it's the same thing. We've got our parallel lines and then our transversal going right through it. So in this one, we're talking about alternate exterior. It's going to be very, very similar to alternate interior. The only difference is it's on the outside of the parallel lines instead of inside. So alternate, again, means opposite sides of transversal outside the parallel lines and then again are congruent. So those are our three parts to it. They got to be opposite sides of the transversal, outside of the parallel lines, and then they are congruent. So again, if I highlight my transversal here, my transversal is cutting down the middle here. And then my parallel lines are running kind of diagonally here here. And then if I make my box again inside the parallel lines, I'm picking angles that are outside of that box. So I've got my inside of the box right here. I need angles on the outside of that box. So maybe the first one that I choose is angle number 1 because it's outside of the parallel lines. So angle number 1 is on the top of that transversal. It's above it. It's on the top half of it. So I'm picking either 4 or 8 because those are my only two outside or underneath that transversal. Now I'm looking which one is going to be congruent to it. Well, angle 1 is a small angle. It's an acute angle. 4 is obtuse. 4 is big. 8 is another acute angle. So 8 has to be the alternate exterior pair. So angle 1 and angle 8 are alternate exterior, which then tells us if we want another pair. If we look at angle 4 we said was obtuse. Angle 6 is also obtuse, so angle 4 and angle 6 would be our other pair. All right, now that we've got our vocab down, I want to go through some application problems. And we're going to start with an easy one, and then we're going to work our way up to some difficult ones. So this first one here says if angle ABC is vertical to angle DBE, and angle DBE is 47 degrees, what is angle ABC? So anytime that we're doing these types of problems and there is just giving you words, pick out the key words. So the big key word in this one is that vertical. So I'm going to write down what I know about vertical angles. I know that they share a vertex. That's the first thing that I know. And if I look, angle ABC and DBE, what do they share? What's the same about both of them? Both of them, in this case, are going to be sharing vertex B. So I'm already starting to think about what that looks like in my head. All right, so they're vertical means they share a vertex, and I know they're non-adjacent, which makes sense because the only letter that they have in common is B. So they can't be directly next to each other because A and C, neither one of those is in my new angle. Makes sense. So they're non-adjacent. And then they're diagonal from each other. Diagonal from each other. Okay, I'm starting to get a picture in my head. They're not directly next to each other, but they're diagonal each other over a vertex. And then the last most important piece to it is that they are congruent. And that's going to tell us exactly what we need to do. Because if DBE is 47, well, what does congruent mean? Congruent means the same degree measure. So if DBE is 47, that means that ABC has to be what? Good. ABC has to be 47. Angle ABC is equal to 47 degrees. All right, next one here is another word problem, so there's no diagram with it. It says if ABC is 110 degrees and is supplementary to angle FGH, what is the measure of angle FGH? So again, we're going to pick out the key word. The key word, what's the key word in this one? Good, the key word is supplementary. So I'm looking at that word supplementary and I'm figuring out what that word means. And the most important thing is that it sums to 180 degrees. That's what we're going to use to help us solve this problem. So if ABC is 110 degrees and ABC and FGH sum to 180 degrees, well, we don't know what that angle is yet. So I'm going to call that X. And I'm going to say that 110 plus X has to equal 180 degrees. Now, This seems like an oversimplification. You're probably thinking to yourself, oh, I could have just done 180 minus 110. Yes, you are right. That's what we're going to do in the next step. However, do the easy problems like this so that way the harder problems make more sense. Because if I go through my steps to solve this one, I'm going to make my t-chart, subtract 110, and I'm going to get x is equal to 70, which means that FGH is 70 degrees. But like I said, do the easy problems like this. Go through the steps. Do it one step at a time on your paper. Don't skip steps, especially on the easy ones. It makes you want to skip steps because it is easy. However, that's going to make you have problems on the harder problems. If you do the easy problems like this, the harder problems don't seem so hard because it's the same process. All right, now we're moving into problems that have a diagram with them. So here we've got two parallel lines cut by a transversal. We've got this angle in here is 93 degrees. This angle is y degrees, and that angle is x degrees. And the directions say to find the missing angles x and y. So anytime that you're finding missing angles and you have parallel lines with a transversal, you have two options. So here I'm going to write down my procedure a little bit, or I'm going to call it my thought process. Thought process. So number one, I'm going to ask myself, are they congruent? So that's the first question I'm going to ask myself. Are they congruent? So let's look at 93 and x first. So I need to know, are they congruent? So when I'm looking at them, I'm saying 93 degrees is right here and x degrees is right here. Well, they sure look like they're congruent, but like I told you guys last time, a lot of times they're not going to be drawn perfectly, and you're going to have to actually use logic and deduction to figure this out. So they look congruent, but do they form an angle pair? Well, if I look at my definitions there, I'm looking at the fact that they are on different vertices. So that's number one. So they can't be vertical from each other because that just doesn't make sense. One's on the inside of the parallel lines, one's on the outside of the parallel lines. So they can't be alternate interior, they can't be alternate exterior. So that leaves me with corresponding. Are they corresponding? Well, this one up here is in the top right of this vertex. This one over here, x is also in the top right. So x and 93 are congruent because they are corresponding. So the 93 degree angle, so 93 degrees, and x are congruent because they are corresponding. Great, that helps us out a lot because that tells us that if they are congruent, my next question is yes. So my next part is yes, they are congruent. And what does congruent mean? So they are the same. So that means that x is equal to 93 degrees. And I'm done with x. I found x. So now I'm going to erase this here, and I'm going to go through that same thought process, but for y. So I'm going to erase this here. All right, now I want to look at the 93 degree angle and y. So I'm looking at 93 and y. So I'm asking myself first, are they congruent? All right, are they congruent? Well, they don't look like they're congruent because this one's big and this one's small, but it's pretty close. They might be congruent. So let's go through our angle pairs. They're on different vertices, so they can't be vertical. They're both on the inside of the parallel line, so they might be alternate interior. However, what makes them not going to be alternate interior? You should have said that they're not alternate interior because they're both on the same side of the transversal, so they're not on alternate sides of the transversal, so they can't be alternate interior. And we already said that this one was corresponding. So are they congruent? No, they don't form a special pair. So are they congruent? No, they're not congruent. So we said no, which means they are supplementary. And just like we did in that last problem, if they're supplementary, that means that we can add them up, set it equal to 180. 93 plus y equals 180. Make my t-chart, subtract 93, and y is equal to 87. So y is 87 degrees. So this one was 87, and this one was 93 degrees. So if they're congruent, great, they're exactly the same. If they're not congruent, then they must be supplementary, meaning that when you add them up, they add up to 180 degrees. All right, so we're at our last step here. This is kind of the hardest problem that we might see. And this one just says to find all of our angles. So we got to find the degree measure of all of these angles. And there's 8 angles in this diagram. There's 1, 2, 3, 4, 5, 6, 7, 8. So it sounds really hard. It sounds like we've got a lot of work ahead of us, but it's not that bad. Break it down into our step-by-step procedure. What do we know? What are we given? We're given this angle here is 2x plus 10. This angle here is 4x minus 30. So when they give us 2 angles, we're thinking to ourselves, okay, maybe they form a pair. Maybe they form a relationship. And are they going to be congruent? I guess I'll write in blue because I'm doing my thought process. Are they congruent or supplementary? So we're looking to see, okay, do they form a special pair relationship? So this one is on the left vertex, this one's on the right vertex. So that automatically rules out they can't be adjacent, they can't be vertical angles, so they must be something else. They can't be vertical angles. Okay, next thing, are they corresponding? Well, here's my vertex. This one's in the top left. If I look over here, the top left is blank. So it's not that one, so they can't be corresponding. Now I'm looking, okay, alternate interior, alternate exterior. Well, if I were to draw my box, make my parallel lines into a box, they're both on the outside. So there's a chance that they might be alternate exterior. So I'm looking at this one here is on the top half of the line, and this one's on the bottom. So in fact, they are alternate exterior angles. And what do we know about alternate exterior angles? They are congruent. So they're congruent, which means that they're the same. So congruent means set them equal to each other. So I'm looking at those 2 angles. I'm going to set them equal to each other. I've got 2x plus 10 is equal to 4x minus 30. So then I'm going to go through my step-by-step procedure. I'm going to make my t-chart. Now I got to get my x's on the same side, so I'm going to subtract 2x from both sides. And that's going to cancel out over here and leave me with just 10 is equal to 2x minus 30. Add 30 on both sides to get x by itself. 2x equals 40. Last step, divide by 2. So x is equal to 20. Am I done? Am I done with my process here? Well, no, because the question told me to find all of my angles, and I just found out what x is equal to. So I'm going to go through and erase my work here. Make sure if you haven't, you copy all of this down. So if you haven't done this, pause the video, copy down this step. Next step is I got to figure out what my angles are. So I know that x is equal to 20. All right. So I'm going to rewrite what we're at. We're at x equals 20. Now what? What's our next step? Well, we need to find all of our angles. So to figure out what this angle is, I know that angle is 2x plus 10. So all I have to do is plug x in. So when I've got 2x plus 10, I plug 20 in for x. I get 2 times 20 plus 10, which is going to give me 40 plus 10 is 50. So I know that this angle here is 50 degrees. Now, you could go through and plug in x there. However, what do we know about these two angles? They're congruent, which means that if this one's 50, this one is 50. Now I can go through my angle pair relationships and figure out which ones are congruent. Now I can look for pairs. So if this one's 50, okay, I'm going to go through my list here. Which one is vertical to it? Well, 50 is vertical to this one, so this one is also 50. Which one's vertical to this one down here? This one up here, so this one is also 50. Just by looking at the vertical angles, I already know all of the ones that are congruent to 50, because this one corresponds to this one, and this one is alternate interior to this one. So I've got all of my pairs that are 50. Now, we've talked about if they're not congruent, what must they be? Supplementary. So if not congruent, then supplementary. Supplementary. So that means that to find my missing angles, I can do 50 plus x equals 180, t-chart minus 50, x is equal to 130, which means all of my angles that I have left are 130 degrees, because they're all supplementary to an angle that's 50 degrees. And boom, I found all of my angles in that diagram. So take it step by step. Look at what they give you. Figure out what information they tell you. Does it form a pair? Does that mean it's congruent? Or maybe it's supplementary. If it's congruent, set them equal to each other. If it's supplementary, add them up, set it equal to 180, solve for what you don't know.